Malgosa, and I'm doing a report on how do we search for life. So the habitable zone is the distance from a star where one can have liquid water on the surface of a planet. So if the planet is close to the sun, the water will evaporate and will be unlikely to sustain life, and if it's further away, the water will freeze up and it will be too cold to sustain life as well. So this is the habitable zone where the Earth is. And here's another image of the habitable zone in the green area. And red is obviously hot, and then blue is cold. So a habitable planet should orbit a star that remains stable in output for a billion years. It should also have a circular orbit. Stars that are larger, hotter, and more massive than the sun, A-dwarfs, have their habitable zone much further out from the star. An absolute requirement for life is an energy source. 100% of the energy that fuels the Earth comes from the sun. To maintain a constant global average temperature, all the sun's radiation that enters Earth's atmosphere must eventually be sent back into space. Everything in the universe is made up of the same stuff. It's just present in different forms and shapes. Some types of energy will prevent life from staying on a planet. You can also find energy on the planet's atmosphere. So here's just like a little image of the sun and how it's giving energy. So 20% is scattered and reflected by clouds, 51% is absorbed by the Earth, 19% is absorbed by atmospheres and clouds, 4% is reflected by the surface, and 6% is scattered from the atmosphere. So as stars begin to age, their luminosity changes and temperatures changes and tend to get cooler, which makes it unlikely to sustain any chance of life. So here's an image of a star aging in the luminosity. So metallicity is, I hope I pronounced that right, is used to describe the abundance of elements present in an object that are heavier than hydrogen or helium. Oxygen, hydrogen, nitrogen, and carbon are important for existence to sustain life. So here's just an image of all of them. The oxygen, hydrogen, carbon, nitrogen. So the Kepler mission was designed to survey our region of the Milky Way galaxy to discover hundreds of Earth-size and smaller planets in our near the habitable zone and determine the fraction of the hundreds of billions of stars in our galaxy that might have such planets. There is now clear evidence for substantial numbers of three types of exoplanets: gas giants, hot super-Earths in short-period orbits, and ice giants. He used a transit method, which is when a planet passes in front of a star and viewed from Earth. So here's an image of the Kepler mission spacecraft, and then here's the exoplanets. And that is my references.